So welcome to Module 1, Part 1. Thank you for everyone that showed up live today. Lots of action, which is great. I did want to show you before you start watching this video, or if you haven't downloaded the notes, if you go to your course messages, I have sent you some information and notes to actually download and print off. So if you look here, you'll have a Word document or a PDF. Choose whichever one you prefer. I do the PDF so it shows up correctly. And when you download it, it will look like this. And basically, these are the notes that correspond to the PowerPoint I'm going to go through. So you'll see there's like these blanks here where you can actually fill in the answer. So, you don't have to write down everything. I have part of it already written down for you. You just have to fill in the blanks or, just answer the questions. So you don't have to copy the problems down, which is also a nice benefit. You just have to finish the problem. So I do that every single week. So you can expect a live lecture notes every single week. Word document and PDF. You'll see that there's part 1 and part 2 notes. So if you didn't do it for this session, go ahead and try it for session 2, part 2, which is on Thursday at 1 o'clock. And it is all new material on Thursday. So it's not like a repeat or anything. So just a heads up. Any questions on the notes or the 2 live sessions, anything like this, this is the normal time. If it changes at all, I will let you know. Okay. Okay, just a heads up, everybody. I'm sorry if my voice goes out or anything because I've been dealing with bronchitis for like 2 weeks. Merry Christmas to me, which has been super awesome. So just a heads up. Anyways, let's go ahead and get started. So what are we going to talk about today? Well, in today's lecture, we're going to talk about algebra, a little bit of its history, just very brief. And then we're going to talk about inequalities. So you may or may not be familiar with inequalities. And they're going to come up a lot more in part 2 of this week. And then we're going to talk about the order of operations. So that probably sounds familiar to everybody, the order of operations. Maybe you know it as PEMDAS. Please excuse my dear Aunt Sally. Maybe not, and we're going to use that to evaluate. So we're going to get into a little problem solving, but this first live lecture is very short. It's just to kind of get you comfortable with the class and to see how it's going to go. Thursday will be a little bit longer and will be tougher. Just a heads up. I don't want you to think every lecture is going to be like this, unfortunately. So just stick with it, right? Okay. So what is algebra? Algebra is a branch of mathematics that deals with operations on sets of numbers and relationships between them. So basically algebra is the step between pre-algebra, which is just working with numbers, to working with what we call variables or letters. So it helps us to create this unknown value, to solve for that unknown. And in life, there's a lot of unknowns, right? Question marks, like what's going to happen? How much am I going to spend on groceries? Maybe you have a budget. But obviously it might be less, more, everything like that. You have unknowns in life. So algebra helps us to quantify or give a number value to those unknowns. And there's lots of different areas of mathematics. You've got geometry, algebra, linear algebra, graph theory, all the calculus, all these different areas. And honestly, you will probably see statistics, algebra, and maybe a little bit of geometry in your life. Most people don't go into this other stuff. So I don't know. Anybody going in computer science? If you're in computer science, you will be going on to that. Okay. So algebra has been around for eons, nearly 4,000 years, and it has been used to advance science, technology. The cell phone that you use is all math, okay? You wouldn't get this without math. It's just the way the world works. Technology and math go hand in hand. Fun fact. And you know, you can see even Egyptians used to use math to help navigate the oceans and everything like that. So it was used all around the world. Very important. Anyways, so that's just kind of a little background on it. Galileo, who's pretty famous, right? He actually said, philosophy is written in that great book which ever lies before our eyes. I mean the universe. But we cannot understand it if we do not first learn the language and grasp the symbols in which it is written. The book is written in the mathematical language, without which one wanders in vain through a dark labyrinth. So basically what he's saying here is that math is a part of us, whether we recognize that or not. Some of us like to deny it. My sister is one of those people. She's not a math fan. Okay. Come from the same mom and dad, but you know, she got the English genes. So, but math is all around us and it's a part of every day. Even when you use your cell phone, which most of us probably use it every day, if not like every little bit. So let's jump into now some vocab. And vocab is very important in this class because I'm going to be using a lot of this terminology as a reference point as we go on. So keep in mind that when you're filling out those notes, vocab is essential. So practice those words. Maybe you want to take your kids and go, hey, I just learned about inequalities, and see what they can tell you about inequalities. That's kind of a fun way to incorporate the family into learning as well. If you don't have kids, maybe annoy your significant other, whatever you want to do. So the first thing we want to talk about is inequalities. And inequalities are those symbols that look like mouths open to one side. They're the arrows. And there's 4 symbols that we use for inequalities. We have greater than or equal to, less than, and less than or equal to. They're really 2 symbols, and the number on the left is the number that's going to be greater than the number on the right, or if you see this less than symbol, the number on the left is going to be less than the number on the right. And the main difference here is the line underneath indicates that the 2 sides could be equal, but they do not have to. Whereas greater than means that the 2 sides cannot be equal. The left-hand side has to be larger. So it's a way to really tell us which number is going to be larger. Okay, so I want you to go ahead. If you don't have the chat box up, go ahead and put it up for me. But just give me a number that you could place in the blank here. So A, this is going to be 2 is greater than. What number? What number could I put there? I could put 1. I could put 0. You bet. 1, 0. I could put -1. I could put -500. Just keep in mind the number line, which we'll talk about more next week or Thursday. I think that is -1, -2, -3. Keep going more negative that way. So any number this direction is larger, and any number this direction is smaller. Okay, so 9 is going to be less than, what number could I put here? 70, I love it, getting creative. 70, 100, 500, 6 billion, whatever you want to say. I could also I could get creative and say 9.1 because 9 is still less than 9.1. Okay, so this one's a little trickier because you're looking at the number line and you're working with a negative number. And I'm going to be honest with you guys, negative numbers are the biggest culprit of mistakes. But we can work through them. So we're looking at -4. Okay, so here's -4 on the number line. And we want to know -4 is less than or equal to what number? What number could I put here? I could put -4, you bet, because that line underneath indicates that the two sides could be equal. What other number could I put here? What do you guys think? Any guesses? And remember, wrong guesses we can learn from, so it's no big deal. I'm not going to judge you. Go ahead and throw out another number. -2, 0. These are correct, -2 or 0, because if you look at the number line, -2 is here, 0 is here. They're both further to the right on the number line, which indicates that they are larger. So if -4 has to be less than whatever number you give me, okay, we can't go to the left because the left has smaller numbers. So -5 wouldn't work, but I appreciate your guess there. So, okay, no problem. Okay, I know you're not the only one thinking that, trust me. Okay, so let's try the next one. This time we're looking at -2. So we're going to look at -2 here. And I just deleted that whole entire number line. There we go. So here we are at -2. And -2 has to be greater than the number you pick. So I could pick -10, -5, -6, -4. These are all great answers. Could I put -2 here? What do you guys think? Could I put -2 there? No, I could not. Why couldn't I put -2 there? And there's no line underneath. It would have to look like this to be able to put a -2 there. Very good, everyone. And you'll see that I'll do that a lot through the live lectures, is ask you that question, why? And that's to kind of push you to get you where you need to go on those written assignments. You want to keep asking yourself, why am I doing that? And that's kind of what you want when you're explaining your answer. And I'll talk about that more. Okay, so I have 4 options here. And I'm asking you which of the following inequalities is not a true statement. So which one of these guys is not correct? Go ahead and take a moment to look through it. Okay, so you guys all guessed D. D is not a true statement. Very good, everyone. -1, when you look at the number line, is here, whereas -3 is over here. And that means that -1 is actually larger than -3. Okay, I'd rather have -1 in my bank account than -3. Basically, owing $1 versus owing 3. And the rest are correct because the line, that can be correct. -3 is greater than -5. -3 is closer to 0, right, than -5. And then -4 is less than 0. Okay, you're owing money. Any questions on any of those other options? Just let me know. I can always go back if I've gone too far. Just type it in the chat box. Can you re-explain that or something like that? Not a problem. So the other thing we want to talk about is exponents. And I don't know if you guys are familiar with exponents, but basically exponents are a shorthand way to show how many times a number, which we call the base, is being multiplied by itself. So here we have an example, which is 8 squared, or 8 to the 2nd power. You can read it either way. And what it's saying here is that we have this base number, and the base number is the larger number on the bottom, 8. And it's saying my exponent, which is the smaller number in the upper right-hand corner, tells me how many times I'm going to multiply this by itself. So it's telling me I need to multiply the base by itself twice. So 8 times 8 is actually 64. So 8 squared is not 8 times 2. It's not that. It's the base times itself. So let's do a couple more practice problems to kind of get used to the base and the exponent. Exactly, Jana. So we want to evaluate the following exponents. So here I have 4 squared. Does anybody know how we would write, what is the answer to 4 squared? Very good. And you know what, Jason? I love that you wrote it out as 4 times 4. Because what we're doing here is we're taking the base, 4, and saying my exponent is 2, so I'm going to multiply it by itself twice, which is, everybody is correct, 16. Okay. How about 5 cubed? Does everybody have their calculator? Okay, so 5 cubed, the base is 5, and the exponent is 3. So as Jason said, it's going to be 5 times 5 times 5, which if we have our calculator, you can go ahead and just pop it in there. And let me finish this first. You will see that it is actually 125. Now, if you don't have a calculator, I'll show you what you can do in just a second. How about 7 to the 4th power? Anybody want to try that one? 7 to the 4th. Dolores, Miranda, yep, you guys are correct. Oh, Brianna, you are as well, and I love that you wrote it out for me. 7 is the base. Your exponent is 4. So you're taking 7 and multiplying by itself 4 times, which, don't worry, I'm not expecting you to do this in your head, is going to be 2,401. Calculators are encouraged in this class. Don't feel like you're cheating if you use a calculator. I actually prefer you to use a calculator. Just a heads up. 8 squared, obviously we've done 8 squared. So why don't we do 9 squared just for fun? Let's do 9 squared just to change it up. Exactly. 9 is your base. 2 is your exponent. So we're going to take our base and multiply it by itself, which is 81. Now, does everybody have a scientific calculator at home? I have a graphing calculator. You are not expected to buy this. You will not need this for this class. It's just what I have from like high school. So you can use that, but in the course, we go to your course homepage. If you look over here in the additional course information, I actually give you a download for a free scientific calculator. So if you don't have a scientific calculator, go ahead and go here, and then it'll just be a download for a free calculator. And it works with Mac or PC, so just Windows version or Mac. Download it, and it's going to look like this. It's going to be like a little app that you can use. It's pretty cool. It's pretty sweet. I use it to demonstrate in my classes. But you can just use on there. So like if you wanted to do 9 times 9, you would just type it in. 81, yay. And the good thing about this one is it's scientific, so it follows the order of operations. You've got to be careful about some of those cheaper calculators because they won't follow they're not scientific. They won't do the order of operations exact. So if you have any questions on the calculator you have at home, just let me know. If you rather have a handheld calculator, I suggest this one. It's like $13 from like Walmart or Target. It's the Texas Instruments TI-30X2S. And it's just a nice little calculator to use. It usually comes in blue. Comes in different colors, but if you're feeling pink, you can get one in pink. Whatever you want to do. I'm just saying it's worth the investment to get a nice one. Okay. Any questions on the calculator? Okay. You're like, I'm all downloading it right now. So now let's move on to our final discussion. I know, we're almost done with the whole entire thing. That was fast. I told you this first session would be pretty fast. So the order of operations are vital because they're going to tell us what operation should come first. What operation is more powerful and is required to do first. So order of operations is, you can read it as PEMDAS, or some of you may have heard it as please excuse my dear Aunt Sally. Some of you may have remembered that like that. But basically the first thing you want to do is you want to do parentheses. And let me preface that with either brackets, braces, some type of grouping symbol. What you're going to do is you're going to simplify what's inside first. Okay, so when you have a parenthesis, do what's inside that parenthesis first. Not what's outside, but what's inside the parenthesis. Or bracket or braces or whatever type of thing. Then you're going to move on to exponents. So that's like the 8 squared or 9 cubed or whatever you have there, okay? Then you'll do those exponents. Then we're going to move on to multiplication or division. Now, this is one area where a lot of people get tripped up. Multiplication and division go from left to right. It isn't multiplication first, then division. It's actually multiplication or division, whatever comes first. So if you had something like 9 divided by 3 times 2, you have division and multiplication, but since division comes first from the left, you'd have to do that first, then multiply to get 6, okay? So do whatever comes first. And the same thing with addition and subtraction. Whatever's first from left to right. Okay. Any questions on the breakdown of the order of operations? Because we are going to get into several examples. Are you guys already like started on them? It's okay. I know it happens. You're excited to get going. Okay, so we're going to go ahead and evaluate the following expressions. When I say evaluate here, I just mean simplify, or in other words, just get rid of all the operations. So, you know, multiply, subtract, anything like that. I'm just going to go ahead and, there we go. Okay. Okay. So let's start with the first one, which is 7 minus 3 times 4. So we want to write our order of operations up here, PEMDAS. Okay, parentheses first. There's no parentheses here. So then we move on to exponents. No exponents here. Then we say I need to do multiplication and division from left to right. Is there any multiplication here? What do you guys think? Yes, there is. So if you guys aren't familiar, the dot symbol actually means multiplication. We try to get away from using the X as a symbol for multiplication, and the reason for that is because we're going to start to use variables, and the variable that we like and use a lot is the letter X. So we don't want to confuse multiplication with a variable. Okay, so just keep in mind whenever you see a dot, that just means you're multiplying those two. Okay, so we multiply that first, drop down the rest of the expression, and then we just go ahead and subtract. So what is 7 minus 12? It is -5. If you're not sure, use your calculator. Not a problem. Just 7 minus 12. -5. Boop, boop. Okay. You have $7. You take away 5, or you take away 12. You owe $5. Yeah. No problem. No need to be sorry. We're all learning. Okay. So let's try B. 9 squared plus 2 cubed. Or you could read this 9 to the 2nd power plus 2 to the 3rd power. Both are correct. So what do you think we should do first? Should we do the exponents or should we do those that addition? Yep, exactly, Dolores and Miranda. We should go ahead and do the exponents first. So what is 9 squared? We actually solved this earlier, so you can kind of cheat and go back. 9 squared is 9 times 9, which is 81. Very good. And then what is 2 cubed? What do you guys think? 8. Very good. 2 cubed is 2 times 2 times 2, which is 2 times 2 is 4. 4 times 2 is 8. You can always use your calculator as well. And so you are exactly right. Just go ahead and add those together to get 89. And 89 would be your final answer. Let's go ahead and I'm going to erase this. We have one more problem on this page. And then we have one additional slide, and then I'll show you kind of what you can do now. Okay, so 6 times 5 minus 3 times 2 squared. Whew, lots going on here. Okay, so I'm looking at this problem, and there's quite a few operations. What do you guys think we should do first? The exponent, exactly. So the exponent here is 2 squared, which I believe I saw the answer above 4. Is that what you guys got? Yes, exactly, Jada. Very good. 2 squared is 2 times 2, or 4. Very good. And then we have subtraction and multiplication. Multiplication is stronger, so we need to do that first. So 6 times 5 is 30. 3 times 4 is 12. And we subtract and get 18. Yeah, looks like Dolores agrees, Miranda agrees. Yep, perfect. Boom. Okay. Any questions on these 3 problems? Anything you would like me to talk about more? Let me know. You can always go back. Okay. Because now we have a more exciting one to do. Yay! Okay. I know you're all thrilled. So let's do PEMDAS. So here we actually have some parentheses to work with. So we need to go ahead and simplify those parentheses first. So doing what's inside, so that would be 7. And then 10 minus 3 would also be 7. So 8 plus 2 times 7 minus 6 divided by 2 times 7. Now, notice that I dropped the parentheses. Okay, I got rid of those parentheses there. The reason I dropped the parentheses is because we simplified the inside. Once I add these together, I've done everything possible inside the parentheses. So that operation is done. Okay, so once you're done on the inside, just go ahead and drop it. Now what we have here is we have some addition, multiplication, subtraction, division, multiplication again. So what should we do first? What do you guys think? There's no exponent, so we don't have to worry about that. We're done with the parentheses. So we want to move on to multiplication. Now, why did we choose to do this multiplication first? Because it comes exactly from left to right. Very good. So 2 times 7 would be 14. And I'm going to drop down the rest. And it is a good idea to just do one operation at a time as you're doing your steps, just until you get used to what you can do, what you can't, that sort of thing. So just for you guys, one step at a time. Trust me, it's better to take your time than to rush these things. Okay, so we multiply 2 times 7. What do you guys think we should do next? We should divide, yes, because the division comes first before the multiplication, so we'd have to do that operation first. So 8 plus 14, 6 divided by 2 is going to be 3, and then times 7. And I'm guessing most of you see that we should go ahead and multiply next, because we're still in that multiplication and division from left to right. So 8 plus 14 minus 21. And then, honestly, guys, just go ahead and type this in your calculator. 8 plus 14 minus 21. And you get 1. If we did it one more step, which is perfectly fine as well, add first. Addition and subtraction from left to right, right? Okay, 8 plus 14 is 22, minus 21 is 1. Okay. And sometimes it's just getting used to your calculator again. Sometimes that can be it as well. Okay. Code phrase. So you heard me talking in the preliminary videos about code phrases for credit. So the first code phrase is going to be Happy New Year. You can put in a smiley face. I don't care. It's up to you. But where you're going to put that, just to make sure everybody's on the same page, is if you go to Module 1, click on Module 1, and you go into Assignments, where I'd like you to put that in is in this Live Classroom 1. So you'll just click on the Live Classroom 1, sort of like you did for the extra credit. Begin that, and then just type in Happy New Year. And then you've already got points. Yay! Well, I have to grade it, but you all know that by now. So, Happy New Year! The other thing I did want to talk about real quick, make sure you submit that too. I didn't do it because I don't want to grade myself. Anyways, the last thing what I suggest you start working on is Module 1. Try to get a start on that. Remember that I said that you can always reply to yourself later on in the week. So try to solve this problem, giving an initial post by tomorrow, Wednesday at midnight. Try to give that a go. And then after you watch the live lecture on Thursday, feel free to reply to yourself and be like, I would actually solve it this way now. You can always do that. That's not a problem. You can also take the Module 1 Lesson 1 quiz. We've gone through all the material that will be assessed on this, so you can take that. The only thing is I might encourage you guys to practice some of the ideas to make sure you're feeling comfortable. Make sure you got your calculator down as well before you take the quiz. That's just my suggestion. And only take the Lesson 1. Lesson 2 we have not gone over. Do not take this. No, no, no. Don't take that one. Any other questions concerning what you can do? You can also start on the written assignment if you'd like to. It's going to make more sense after the Thursday live lecture. Questions, concerns? They're not all going to be this easy. Sorry, Jason. Thursday will be a lot. It will be a full hour. It'll be more intense, but I just wanted to start off kind of easing you into it. So. All good. Okay, well, if you don't have any questions, you are free to go. You can always email me later on, not a problem. And then hopefully I will see you all on Thursday at 1 o'clock Central Time, I should say. Have a great day and good luck for week 1. See you Thursday. Bye, everyone. Yes, Taylor, that's a great question. I will always record all of the live lectures. So if you watch a recording, as long as you have that code phrase, you can go ahead and submit it just the same as if you were attending at 1. I just like when you guys attend because you can ask questions during the live lecture. So that's the only reason. But I'll have the recording up as well if you'd like to rewatch it. I have some people that like to rewatch it a couple times before they take the exam as well. So keep that in mind. Okay? Sound good? Perfect. Okay. Well, you guys all have a wonderful couple of days. I'll see you on Thursday. Bye, everyone.